Okay, so this is Unit 3, Objective 4/5, because we're doing Worksheets 4 and Worksheet 5 today, the odds for both of those worksheets. And because of that, I thought I would just do some of the evens and explain them as we're going along. Okay, so on Worksheet 4 at the beginning, it says completely factor the polynomials. Now, when it does say completely factor, it is understood that it means completely factor over the integers. So, for example, problem number 2, x to the fourth minus 15x squared minus 16. Trinomial, although we always look for a GCF first, the GCF is 1. I notice that x squared, the middle term, that power is half of the highest power. So that means we have hope of factoring it as a trinomial. So, two sets of parentheses. Now, x squared times x squared will give me the x to the fourth. It also gets me the x squared in the middle. And negative 16 and positive 1 will get us the negative 16 at the end, and it also gets us the negative 15 out in the middle. Okay, now, we might be done, but be suspicious, see if you can do some more. Now, what about x squared minus 16? That's difference of squares again. So, x minus 4, x plus 4. Now, the x squared plus 1. Technically, if we don't have the completely factor, if we don't have that over the integers, we can factor this using imaginaries. But really, we're completely factoring over the integers. So, x squared plus 1 does not factor any more over the integers. Let's go ahead and try number 4. So x to the fourth minus 25x squared. Always look for a GCF first. There's a GCF of x squared. And x squared minus 25 obviously factors as difference of squares. Okay, let's take a look at number 6 also. Negative 2x to the third plus 2x. There's a GCF 2 or negative 2. You could possibly do it either way. And also the GCF of x. So 2x or negative 2x. Well, a lot of times, look at the highest power of x. Is the highest power of x positive right now? Now, it's kind of nice to have the highest power of x positive. And so therefore, I'm going to take out a negative GCF. So negative 2x, and that would leave behind positive x squared and minus 1. Well, that's nice how that happened, because now I have x squared minus 1, and so that we definitely recognize that as difference of squares. If we only pulled out the positive 2x, I mean, it's still difference of squares, it's just not as recognizable. So negative 2x times x minus 1 times x plus 1. Now, mostly we are graphing, but when we are graphing, it's to our advantage to have things in the factored form. And so directions are factor, sketch the graph, label the intercepts. So let's take a look at number 8. Number 8, we're graphing y equals f times g of x if f of x equals x and g of x equals negative 3x squared plus 12. Now, we've done operations with functions before. We haven't done the times yet. But if we had f minus g of x, we're doing f of x minus g of x. If we had f plus g of x, we are doing f of x plus g of x. So f times g of x really means f of x times g of x. And that's what we're actually graphing. So since we know what f of x is and we know what g of x is, that's what we're dealing with. So we have y equals x times negative 3x squared plus 12. Now, yes, you could distribute the x, but aren't we going to want it in factored form anyway? So it's already partially factored. Let's continue the factoring. There is a GCF of negative 3. Could do positive 3, but negative 3, see the highest power of x there? It's negative. Let's make it so it's positive. So let's pull out the negative 3. So y equals negative 3x with the other part of the GCF out front there, times x squared minus 4. We go, oh, we recognize that difference of squares. So y equals negative 3x times x minus 2 times x plus 2. Okay, so this is what we're actually graphing. Now all the other things we've been practicing come into play. So we recognize that this is really negative 3x to the third plus stuff. And so we know that this is a high to low. We see that our roots are x-intercepts in this case because they're all real roots. Our roots are 0, 2, and negative 2. Now, since the multiplicity is 1 for each of those, I didn't write down the multiplicity. It's understood that they're multiplicity 1. Okay, and the y-intercept, if I plug in 0 for all the x's, negative 3 times 0 is 0, and then times another number is still 0. So the y-intercept is 0. Okay, so let's sketch this. Starting high, ending low. Multiplicity of 1 for each one, so they each go through. Label the intercepts. And there it is. Okay, let's also try number 14. G of x equals negative 5x to the fourth minus 10x to the third plus 75x squared. Well, it's already multiplied out, so we can already see it's a negative 5x to the fourth. So it is a low to low. By the way, if we plug in zeros for all the x's, we can see that the y-intercept is 0. Okay, factoring. My highest power of x is negative. I'm going to plot a GCF of negative. Negative 5x squared, it looks like. And then the x squared plus 2x minus 15, factor some more. And so we have roots of 0, multiplicity 2, negative 5, and 3. Okay, sketching. Starts low, ends low, bounces only at 0. Starts low, ends low, bounces at 0. So starts low, goes through, bounces, goes through, ends low. Now, by the way, it also asks some questions. Says, how many x-intercepts? Well, 1, 2, 3. How many relative maximums? Well, here's one. Increasing on one side of it, decreasing on the other side of it. Here's another one. How many relative minimums? Well, there's one right here. Okay, picking up where we left off, I'm now in worksheet 5. Worksheet 5, the beginning problems factor completely. This time it actually says over the integers. So number 8. Now at first glance, maybe you're thinking, oh, I need to multiply this out before I can factor. But let's take a look. Let's look at the things in the parentheses. 2c minus d is almost, it's very close to being the same thing as d minus 2c. So in fact, can we get the things in the parentheses to be the exact same thing? Perhaps maybe if we factor out a GCF of -1 out of one or the other. Well, this one's already 2c minus d. So if I factor a -1 out of the d minus 2c, so that would be -1 times x squared, and it would become negative d and plus 2c. Now, is negative d plus 2c the same thing as 2c minus d? Yes, it is. Now, typically, once you kind of get used to this, you'll probably, as you factor out a negative, you'll probably factor out the negative and even have them switch places. So the positive one's in the front, and the negative one's in the back. Now you look and you go, oh, yes, there's a GCF of 2C minus D. So we bring the GCF out in front, 2C minus D, and what's left behind? 9. So 2C minus D times 9, that gives me the 9 times 2C minus D, minus 2C minus D times x squared. So GCF of 2C minus D times the 9 minus x squared. Now, maybe we're done. Be suspicious. What about the 9 minus x squared? Well, we could factor that as difference of squares. So 2C minus D times 3 minus x times 3 plus x. Now, depending on how it was done, somebody else could have factored out the negative out of the first one. And so another possible way for it to look, it could be looking like D minus 2C. And if that was the case, it would have been x squared minus 9, which means we'd have x minus 3 times x plus 3. These are equivalent. Either one is correct. Okay, let's try problem number 12 now. Problem number 12, you got 3w cubed minus 3w squared z plus 18w squared minus 18wz. Now, since there are 4 terms, a lot of times when we see 4 terms, we immediately jump to the grouping type of factoring. If we look for a GCF first, there is actually a GCF of 3w, and so that is kind of nice to do, but we will get that GCF as long as we finish the job. So it's kind of understandable if you see 4 terms that you immediately do the grouping. And we haven't done any grouping yet, so let's go ahead and I'm going to go ahead and do it by grouping. I'm going to go out of order and not do the GCF first. So how does grouping work? You should have seen this before, but just to remind you, generally you group the first 2 and the last 2. And you do a GCF of the first 2, and you do a GCF of the last 2, and then we have to continue finishing. Now, it's not always first 2 and last 2. It could be the first and third, second and fourth, or outside 2 and inside 2, but it's usually first 2, last 2. So let's look at the first 2. GCF of 3w squared. Okay, now ignore the first 2, and let's get the GCF of the last 2. So GCF of the last 2 is 18w. Might be positive 18w, might be negative 18w. We won't know for a second. I'm going to do positive to begin with. And so if it's positive 18w, I would have w minus z. Okay, now that I've done that, let's compare the stuff that's in the parentheses. Is the stuff in the parentheses exactly the same? Yes. So that's good. That means that we can continue on with our grouping. Now, if it wasn't, if they were opposites of each other, sort of like what happened in the previous problem was actually grouping. It's just they'd done the first step for us. And so if they were opposites, that's where you'd have to factor out a -1 so that you could get them to be the same. So I could have factored out a negative 18w and they would have been the same. But these are the same already, so we will continue. There is a GCF of w minus z. So we'll pull that out in front, w minus z. And what's left behind? Well, 3w squared plus 18w. Now, maybe we're done, but wait, maybe we're not. We gotta look. So look over here. We go, oh, there's a GCF of 3w. So 3w times w plus 6. Don't forget the w minus z. Okay, technically this is factored as much as we can. However, when we have a GCF, we don't put the GCF in the middle. We put the GCF out in front. So 3w times w minus z times w plus 6. Okay, doing problem number 20 from worksheet 5 together. Now problem number 20 is saying f minus g of x. Well, it actually says f of x minus g of x. But remember, if they say it like f minus g of x, it's really saying f of x minus g of x. So, well, f of x is 4x to the fourth plus 8x to the third. And g of x is 16x squared plus 32x. And we have to subtract them. So the function we are actually graphing is y equals 4x to the fourth plus 8x to the third minus 16x squared minus 32x. Now, it's not in the factored form. There are some advantages for when we're not in the factored form. For example, you can easily see that the degree of the function is 4, and it's positive 4x to the fourth, and so therefore we know this is a high to high. And if we plug in 0 for all the x's, we do get the y-intercept of 0. Okay, but to really be able to do anything else, we need to get it in factored form. Okay, so here we go. 4 terms. Going to do grouping. First two, GCF of 4x cubed. Times x plus 2. So I'm trying to get an x plus 2 in this second set of parentheses. So there's the negative 16x squared minus 30. They're both negative. So I think I'm going to pull out a GCF of negative 16x. And that would leave me with x plus 2. And so that's good news because we have x plus 2 as a GCF now. So x plus 2 times what's left behind, 4x cubed minus 16x. And we look at the 4x cubed minus 16x and we go, oh, there's a GCF of 4x. X squared minus 4. Don't forget about the x plus 2. And x squared minus 4 is x minus 2 and x plus 2. Okay, so if we multiplied all that out, do we still have a positive 4x to the fourth? Yes. Okay, we like to bring the GCF out to the very front. So 4x times, now notice we have two x plus 2's. So x plus 2 quantity squared times x minus 2. And that's the function, so y equals. So now we can see that the other roots, which are all x-intercepts, they're all real numbers. So we have 0, multiplicity 1. We have negative 2, multiplicity 2. And we have positive 2, multiplicity 1. Okay, so sketching the graph now. and it is a high to high, and it bounces at -2, goes through at the others. So it starts high, bounces, goes through at 0, and goes through at +2. Label the intercepts.